But the nature of that life was very simple. It was essentially microbes, single-celled, very simple organisms, so, prokaryotic cells, if you're familiar with that term. And the Earth, during most of the Precambrian, is dominated by those organisms. In fact, if you would have visited Earth in a time machine at any time between the time life originated 4 billion years ago and the time of the first animal bodies, let me put it this way. If you would have visited Earth at any time between about 4 billion years ago and 600 million years ago, you would have needed a microscope to see life. Because we don't have animal bodies until around that time. You couldn't have seen any living thing. The world was dominated by microbes for most of its history. In fact, it's still dominated by microbes. But for most of its geologic history, there was nothing but microbes. So single-celled organisms. We go from 4 billion years, we find the first simple cells. 2 billion years ago, we start finding more complex eukaryotic cells, the cells that are needed to make the bodies of animals, plants, and fungi. There are basically 2 billion years there before we even have the basic cells that we need to build a body. And then around 750 million years ago, we start finding in the rocks the first evidence of animal-like cells. And we actually, around 630 million years ago, start seeing some primitive animal bodies like sponges. We move forward all over the world. Around 575 million years ago, we start finding a collection of animal bodies, often referred to as the Ediacaran fauna. So we start seeing animal bodies around 575 million years for the first time on an Earth that has had life, since 4 billion years ago. And then, not long thereafter, around 520, maybe 540 million years ago, we see the evidence for the first chordates. Bodies start to diversify on this planet, and we see the first chordates. We belong to the phylum Chordata, right? We are chordates. And so we see the first chordates beginning around 520 million years ago or so. Here's an example of one. A little fish-like thing called Hycuichthys. I think it's a great name. But one of the things that's interesting about this little fish is that it didn't have a skeleton. Right? It's a soft-bodied organism. It didn't have a lower jaw, right, like we do. It doesn't have a jaw. It was very worm-like in many ways. This, by the way, is another example of an early chordate. It looks more like a worm than it does a fish. And we have things like these still alive today. It's a little soft-bodied invertebrate organism that is a chordate. And later on, as we move not too far up the geologic column from the time we find those first chordates, we start to see early fishes without jaws. And then a little higher, we start finding fishes with jaws, like this fish called an acanthodian. And we talked just a short time ago about the development of our own jaws. In these early fishes, in these early fossil fishes, we see that the jaw, the lower jaw, is basically formed from modifying that first gill arch, right? Something that we do, something that humans do every time a new human is conceived. That first gill arch becomes the lower jaw in development. And we see this also happening for the first time in fossil fish. There's also a specific group of fish called the lungfish that develop a little bit later. And lungfish are incredibly important, not only because they have a modified swim bladder that can serve as a lung, very primitive lung. They basically have oxygen that moves through that to get into their blood. They can go to the surface and gulp air. But they also have limbs that essentially their fins are attached to. And those little fishy lobes have all the same bones in them that we have in our own limbs. In fact, we can see these transitions in the rocks. We can see a time in which the same bones that make up our own limbs are found in these fishes with lots of little digits supporting the fin. And then we see organisms with many digits, like this Acanthostega with 8 fingers instead of 5. And then ultimately, we start finding a lot of amphibians with 5 toes, 5 fingers and 5 toes, just like us. And just like almost every other terrestrial vertebrate, 5 fingers and 5 toes. But first, we see this transition in the rocks. To get to that point, we see these patterns, right? These patterns emerge. And so eventually, these organisms leave the water. So amphibians are probably familiar with amphibians like frogs and salamanders and so forth. As you probably know, frogs and salamanders don't have claws, and they must return to the water to lay their eggs. And from amphibians, around 320 million years or so ago, we get reptiles. The first reptiles, we find them in the fossil record, with their claws and with their stronger jaws, and most importantly, with an egg called the amniotic egg. It's an egg with a hard shell. And so they didn't have to go back to the water to lay their eggs. They could lay their eggs in a rotting log. They could lay their eggs on land, and therefore becoming fully terrestrial. And so we see this happening for the first time in reptiles. And as we move up even further in the geologic record, we see a group of reptiles that are often called therapsids. Reptiles, they're actually transitional between reptiles and mammals. They start taking on some mammal-like characteristics. If you think of a mouth of a crocodile, it has just sort of all these random teeth in its mouth, right? Sharp, pointy teeth that are seemingly random in their distribution. You don't see any strong differentiation in the size of the teeth in the mouth. But beginning with this group of mammals, I should say mammal-like reptiles or therapsids, within this group, you start to see their teeth become differentiated. You see big canines, right? And post-canines and incisors, just like us. Well, not just like us, but becoming more like us, becoming more like mammals. They also, if you think of crocodiles, they have their bodies out to the side, their limbs out to the side of their body, right? They have a sprawling gait. But these reptiles have their limbs directly below their bodies. They have an upright gait, more like a dog than a crocodile. There's also some evidence that they were warm-blooded, and some therapsids show evidence of at least pits in the snout for whiskers, hair, right? We see some evidence for hair present in these organisms. Beginning really during the time of Pangea, right? Around the time of Pangea is when we see the development of these organisms.